Hi students, Sukumar here. Definition for electrostatics. Electrostatics deals with the static electric charges, the force between them and the effect produced in the form of electric field and electric potential. Electrostatics, only this chapter tell about properties of static electric charges. Properties of static electric charges. Movable state of electric charges are called as dynamic electric charges. So electrostatic, what do you understand from electrostatic? Only you studied about properties of static electric charges. So next, the force between them and the effect produced in the form of electric field. The force between them effect produced in the form of electric field. It's mean that we see an example. A addition of the charge and B another charge. A produce effect on B produce effect on A. Lines of forces, electrostatic lines of forces exist between the two charges. So it is one of the field region. It is one of the field region. We see one more example. We select a bar magnet. North pole of the bar magnet, south pole of the bar magnet. Magnetic field lines of forces are traveling from north pole to south pole. Magnetic field lines of forces starting at north pole and terminate at south pole already know. So magnetic field lines of forces propagating within the region, it is called magnetic field region. Magnetic field region. So effect produced in the form of electric field. Effect produced in the form of electric field. Next, second one is current electricity. Already you studied about second lesson, current electricity. This one is tell about properties of movable state of charges. Next, third one is charges are present everywhere. Charges are present everywhere around us. Through their presence can only be felt under the special circumference. Under the special circumference. This one is a very important point. Next, for example, when we remove our sweater in winter on a dry day, what happened? We hear some crackling sound and the sweater appears to stick to our body. So charges are produced due to the friction. Charges are produced due to the friction. Continuously charges are produced due to the friction. So we see another example, one more example. Charges are produced due to the friction. We see one more example. We select a comb. It make a friction with a piece of paper. We select a comb. It make a friction with a piece of paper. What happened here? Charges are produced due to the friction. Charges are produced due to the friction. So for always charges are produced due to the friction. In this case also already know. Next, we see about what are the basic properties of charges. Electric charge, we know that electric charge is a basic property of elementary particles of which matter is made up of. So what are the elementary particles? First one is proton. Second one is neutron. Next, third one is electron. Proton get positive polarity. Neutron uncharged particle, chargeless. Next, electron get negative polarity. Next, proton, neutron, electron. So these are called as elementary particles. These particles are called as elementary particles. Atoms are made up of these particles. And matter is made up of atoms. A proton considers positively charged particle, electron to be negatively charged particle, neutron electrically neutral, so it has no charge. Already very important thing, proton and electron, they are get same magnitude charge value, Q is equal to E, but proton get positive, electron get negatively charged particle. An atom, atomic nucleus is made up of proton and neutron. already you know. You select a sector of atom. Center part of the atom is nucleus. Within the nucleus, proton and neutrons are placed there. Electron revolving around the nucleus. Already know about structure of atom. Why an atom is electrically neutral? Number of positive charges is equal to number of negative charges. So an atom is electrically neutral. Already know about structure of atom. Within the atom, center part of the atom is nucleus. So proton and neutrons are placed there. Already know about structure of atom. So here, very important thing, negatively charged electrons surround the nucleus so as to make an atom electrically neutral. So why the atom is electric? Second important basic property, quantization of charge. Second one is quantization of charge. So charge on an object can be increased or decreased. Charge on object can be increased or decreased in multiples of E. Here what about E? E, magnitude of charge of an electron. Here value for E 1.6 into 10 power minus 19 coulomb. So E, fundamental unit of charge, already you know it is, because during the charging process an integral number of electron can be transferred from one body to other body. Already know an integral number of electron can be transferred from one body to other body during the charging process. Already know. So this is known as quantization of charge. This is known as quantization of charge, or otherwise you can say discrete nature of charge. Otherwise you can say discrete nature of charge. Next, the minimum value of charge on an electron as determined by the Millikan-Oil experiment. Second lesson, second volume, you guys studied in second volume, sixth lesson, how magnitude of charge of electron is equal to 1.6 into 10 power minus 19 coulomb by using Millikan-Oil experiment, how we can be determined. Next, you guys studied the value for E 1.6 in 10 power minus 19 coulomb. This one is very small value. In one or two cases this one is negligible condition. In one or two cases this one is negligible condition. So E, this is called elementary charge, otherwise you can say fundamental unit of charge. Already you know following previous video. Here C stands for coulomb, which is the unit of charge in SI measurement system. In SI measurement system, since proton, positive, electron, negative are charged particle constituting matter, charge on object must be integral multiple of plus or minus E. So by we select sector of an atom by using fundamental unit of charge. How we can be determine charges? We following this method. How we can be determine charges? Minus 1E, plus 2E, and minus 3E by using fundamental unit of charge. How we represent the charges? Next, any charge represented by Q is equal to Ne. Here n is equal to 0, 1, 2, 3, etc. The value for n. Next, any charge represented by Q is equal to Ne plus or minus Q is equal to Ne. Here where n is an integer. So any charge represented by Q is equal to plus or minus Ne. For example, substitute value for n is equal to 3. The magnitude of charge value, how we can determine Q is equal to 3 into 1.6 into 10 power minus 19 coulomb. Suppose you substitute value for n is equal to 3, magnitude of charge value Q is equal to 3 into 1.6 into 10 power minus 19 coulomb. By following this method, we can be determined.
In this video, we will discuss about quantization of charge. Charge is a conserved quantity. Conservation means existence of a quantity in a discrete or discontinuous manner. So, charge is a quantized quantity. First, we define what is quantization of charge. Charge on any body is found to be integral multiple of charge on electron and never found as fraction of charge on electron. First, we understand quantization with the help of an example. If we buy eggs from a shop, we can buy one egg, we can buy 2 eggs, we can buy 3 eggs, but we never have an option to buy 1.5 egg, 2.5 eggs, 3.5 eggs. So eggs are found in quantized form. Similarly, we can buy 1 apple from a shop, 2 apples, 3 apples, 4 apples, and so on. We cannot buy 1.5 apples or 3.7 apples because apples found in such a way that their nature is quantized. They are not available in a continuous form. So the existence of a quantity in a discrete manner or discontinuous way is called quantization. Similarly, charge on a body is also a quantized quantity. Whenever we charge a body, the total charge on a body is found to be integral multiple of electronic charge. Total charge on a body may be equal to 1 electron, 2 electronic charge, 3 electronic charge, or n times electronic charge. So the total charge on a body may be equal to n times E or equal to integral multiple of electronic charge. This is known as quantization of charge.
Next, conservation of charge. We know that when a glass rod is rubbed with the silk, it becomes positively charged. Silk becomes negatively charged. What is the reason? Already you know about this experiment. Follow previous video. Glass rod get positive polarity, silk cloth get negative polarity. What is the reason? Glass rod lost few number of electrons, so it get positive polarity. Silk cloth gain same number of electrons, so it get negative polarity. Already you know about this experiment. Follow previous video. Next, the amount of positive charge on a glass rod is found to be exactly same as negative charge on the silk. So glass rod get positive polarity and silk cloth get negative polarity. Thus, a system of glass rod and silk together possess zero net charge after the rubbing process. So result and conclusion of this experiment can be generalized, and we can say that in any given physical process, charge may get transferred from one part of the system to another, but the total charge in the system remains constant. Or for an isolated system, total charge cannot be created nor destroyed. For example, A, one part of the system, B, another part of the same system, charges are transfer from A to B at the same time, B to A. So for an isolated system, total charge cannot be created nor destroyed. So this one is very important thing. Next, in simple word, the total charge of an isolated system is always conserved. Very next, which type of force is formed between the two number of charges? Next, we follow here. Force between the two charges. Electrostatic force, it can be classified into two categories: electrostatic attractive force and electrostatic repulsive force. So which type of forces form between the two charges? Next we follow here. It was observed in carefully conducted experiment with the charged object that can experience force when brought to close to each other. This force can be attractive or repulsive. Like charges repel each other and unlike charges attract each other. How it is possible? We follow this example. Negatively charged rubber rod, it is brought closer with positively positively charged glass rod. Negatively charged rubber rod brought closer with positively charged glass rod. Both they are attract each other. Negatively charged rubber rod attract the positively charged glass rod. Positively charged glass rod attract the negatively charged rubber rod. So unlike charges are attract each other. One is positive, another one is negative. So unlike charges are attract each other. You understand from this first example. Next, second one is negatively charged rubber rod brought closer with another negatively charged rubber rod. What happened here? Both they are repel each other. Both they are repel each other. Following from the second example. Okay, thank you.